Hello, everybody. Sorry for the delay. We had a bit of an AV issue, but we're all set now. I'd like you to give a warm PyCon welcome to Jiaqi Liu.
Thank you. Good afternoon. Welcome to my talk on building a data pipeline with testing in mind. Thank you for bearing with us as I went through some AV troubles, as I have one of those new MacBooks that only have a USB-C port, and I swear it only works 50% of the time. My name is Jiaqi. I am a software engineer at Button. Button is a mobile e-commerce platform startup based out of New York City. What we do is we are a marketplace that facilitates transactions between publisher apps and merchant apps, and we allow publisher mobile apps to drive more revenue to their apps. We allow merchants to acquire users. As a result, we work with a rich variety of data, both from our publishers, which range from loyalty apps to content-based apps, and from our merchants, which range from retail apps to travel and digital goods. The agenda for today is we'll talk a little bit about what a data pipeline is, why it can be so hard to test and monitor data pipelines, and what some features you will have to design and architect into your data pipelines to ensure that you can test and monitor them, and then what a full-fledged monitoring, testing, and alerting system could potentially look like. So what is a data pipeline? At a very high level, most data pipelines follow the ETL structure, with E being the portion where you extract data. The T part is transforming the data, and this is where the core business logic sits. And it's typically where you would be joining the data set with additional information, or working through a machine learning model, or aggregating the data set for a rough analysis. The load step typically involves loading the data into a data warehouse or and to a user-facing dashboard, or in our case, sending a webhook and sending a transaction to a user-facing experience. I want to walk through a little example that I put together. One of this is I pulled all the talks from the PyCon website and as an HTML blob. And this blob contains information about all the talks, who the speakers are, where the talks are located. This is essentially the extract portion of the data pipeline. I pass this information to, I pass into an array. I split it by the endline character, and I try to format it into a way that is more human readable. So here I parse it into a dictionary of description with the room, speaker, time, and title. And then I do something fun and try to pick a random talk out of this list of talks to try to decide what to go to. And then I can, in the last step of this pipeline, I load the dictionary into a CSV and dump it out into CSV, and this is sort of the load step. At a high level, this is what we went through: extracting the data from the PyCon website, converting it from HTML to structured data, and then selecting a random talk, but also for, on the other direction, writing it to a file. This is really fun, really straightforward. What could go wrong with this pipeline? It's a little bit more complicated than that in real life. At Button, our pipelines tend to look more like this. Don't worry about trying to read the small fonts. Essentially, all of our merchants send us different data sets. It's all very interesting, and as a former data scientist, I love looking through them. But on the other hand, these data come in different schemas, different formats, and even the extract step, they look different because some merchants will send us data in batch files, and some of our partners will send us data via webhooks or via streams, which brings me to the other concept in data engineering, which is batch versus stream processing. Batch is refers to periodic processing of data that arrives in bulk, usually from a file system, but it could also be a periodic scrape of a database. Stream refers to a more high throughput, low latency system that reads data continuously off of a stream or a queue. There are a lot of different tools that help you orchestrate these data pipelines. Some of the popular ones are Luigi, Airflow, Google Dataflow. At Button, we use Pachyderm because it is completely containerized, and we like putting everything in Docker containers. So going back to what could go wrong, I won't focus specifically on any of the tools I mentioned. I just wanted you all to be aware of them. But the concepts I'm outlining here would be applicable to any data pipeline using any infrastructure. There's actually a lot of things that routinely go wrong with data pipelines. One of the common ones is batch job is just never scheduled, or it takes too long to run and your data gets stale. On the stream side, you often see streams get backed up, but the more challenging problems to diagnose are the ones that are not easy to see. Like for instance, if the data is malformed or corrupt, or if you accidentally dropped some data sets or lost some data sets, particularly in the stream case, if you fail to read some of the data in the queue, or if you read the data in the queue too many times and now you have duplicate data in your system. And one of the most biggest challenging systems is working with non-deterministic models. So if you work with a machine learning system, it is incredibly hard to monitor and detect if it's behaving the way that you expect it to. Here are some signals that we use to track batch jobs. So these spikes indicate when the data is being loaded and therefore when the job is run. It's incredibly important to have visibility into information, basic information like this, to see, hey, my job is running. If you stop seeing these spikes, in this case, where the green spikes sort of slow down later on, it begins to open the question of did my job stop running, or maybe I just had a period of time where there was a lot more data than usual. With stream jobs, you want to monitor for the ingress and egress of the queue, the latency of how you're reading the data, as well as the oldest age of the message that's currently in your queue. To summarize, essentially there are two core concerns. One is in terms of time and delayed processing, and the other is in terms of data integrity. Both of those are incredibly critical to core business operations, especially depending on what your SLA relies on and what your customers expect out of your data. As such, it's not enough to understand that a data pipeline is healthy. You also have to know if the data being processed through the pipeline is considered accurate. And this brings me to two very popular terms in the industry: interpretability and observability. You want to architect your data pipelines so that they support concepts from both worlds. So what does interpretability mean? Interpretability is a concept from data science. It means that it's not enough to just understand what a model predicted, but also why a model made a certain prediction. It allows for debugging and auditing machine learning models. It's particularly important in this day and age because interpretability is what allows good security practices and good privacy practices, especially when you're working with customers' private data. Without interpretable models, you cannot guarantee that your models are fair, and you cannot guarantee that you haven't introduced bias into your model in some way or form. Because Button is a marketplace, we see the side effects of user behavior in our data, and we have to decipher what assumptions are safe to make, and we have to use our data to decipher what the initial customer behavior was like and what our desired impact on our customer experience is. Observability is a concept from DevOps and reliability engineering. To me, it's the DevOps equivalent of interpretability. There's a really wonderful blog post on monitoring observability by Cindy Sudharan on Medium. I encourage you to check it out. I borrowed this image from her blog post directly. And it refers to the concept that monitoring covers predictable failures, routine failures that you expect to see. And testing is your best effort at verifying known edge cases and known happy paths. But observability is the world of all possible failures and partial failures. It's not suggested, nor is it feasible to monitor for all possible failures. And it is every data engineer, reliable engineer's dream to be able to have a system where your monitoring system can tell you all the known possible cases, and you know how to resolve every known possible case of failure. But unfortunately, there's edge cases, new edge cases in production, new system failures happening all the time, and you cannot guarantee the reliability of a system. Therefore, observability allows you to capture all the information that might be too much for your monitoring system, but is really impactful when you have new edge cases that come up and allows for your developers to easily debug those cases. All of this leads to having a mystery-free production system. At Button, it is core to our engineering culture to have a mystery-free prod. If something goes wrong and gets escalated but magically resolves in less than 2 minutes by itself, we still want to dig into why that happened and why it resolved, and if it's a symptom of a bigger system failure. So this brings me to talking about the data pipelining features that support interpretability and observability. These features include having a well-defined schema, being able to capture metadata about your data pipeline, and having a test run feature so you can see the outputs of your pipeline before you run it against the production database. Going back to my earlier example of pulling talks from the PyCon talk website, I had an implicit schema where I assumed that there would be a title, a speaker, a time slot, a room, and a description for every talk. There was nothing in my code that enforced this schema, and in fact, I also assumed that the rooms would be valid rooms within this conference hall. If I were to be a little bit more strict in that code, I could at least enforce that the rooms have to be valid conference rooms in this conference hall. I could have also enforced that all of these values had to be strings. There's a lot of tools that help with serializing data and providing schemas. One of which that I'm going to talk about today is protobufs. So protobufs are a Google offering for serializing structured data. And if I had built this with protobufs, this equivalent schema would have looked something like this, with the rooms as enums and defined strictly for each field as a string. Moving on to providing metadata about your data pipeline. Here are some metrics that technically you should also monitor for. But it's incredibly helpful to know at a high level what are some base metrics that you want to gauge to get a sense of a sanity check for your data pipeline. There's 95 talks. The average length of a description is 836 characters. Those all sound very sane to me. In a more rigorous machine learning model, you probably want to have metrics like precision and recall of the algorithm. What are some examples of false positives, some examples of false negatives? And this is also incredibly helpful, and the next feature I'm going to talk about is having a dry run mode. In your test dry run mode, you end up running the data before you can actually put it into a production database. By having metadata available to gauge the success of your pipeline, you're then able to see if the pipeline looks sane without having to spot check every individual data point in your pipeline. Monitoring testing data pipelines is very different from monitoring web services, but there's a lot of common analogies. In particular, you do still have to have the health check which in the data pipeline world is checking that your job has succeeded, and in the web world, it's checking that you get a 200 status code. You still want to have integration tests, and you also want to measure latency. So let's talk more about testing. The test pyramid is something that is quite well known in the industry. I took this image off of Martin Fowler's blog, but it originally comes from a book about Agile. I want to carve out spaces for 4 different types of tests within the data pipeline: the unit test, a functional test, the regression test, and the system-wide test. I won't talk too much about unit tests, as that's not the purpose of this talk, but essentially you should definitely have unit tests within your data pipeline. A functional test to me is for a deterministic system. It's knowing what data in and data out is supposed to look like for your pipeline. And then a regression test is more for a non-deterministic system, but you should also have them for your deterministic pipelines. And a good example of a regression test is the champion-challenger model in data modeling, where you run 2 models in parallel, and then you measure the precision and recall of both, and whichever one over a span of time ends up having a higher precision sort of wins out. System tests allow for black box testing, and it's really good for measuring the whole system health. It typically runs continuously, and it's part of your CI/CD process, but you do have to rely on additional signals to actually diagnose the root of the problem. Regarding monitoring, there's a lot of popular monitoring tools. At Button, we use Prometheus for time series metrics, Grafana to visualize those time series metrics, and Nagios for our system health checks. So our system tests run on Nagios, and Nagios would trigger a status of success or failure for those integration tests. This is an example of a dashboard for a Kubernetes cluster, and it shows basic system health like network I/O pressure, the amount of memory being used, and the CPU usage. And this is an example of what a time series metric provided by a data pipeline looks like. Because you want to measure when the last time a successful job was run, we send to Prometheus a gauge metric that just tells the Unix timestamp of when the last successful batch job occurred. In addition to that, to measure latency for the data pipeline, we also send the delta between when the job started and when it finished. This allows us to put alerting in place, such that if the batch job fails, or if the batch job doesn't succeed within X amount of hours, we trigger an alert, and that gets escalated to the on-call engineer, and they're able to investigate the situation at hand. Some things I want to call out. We're able to use histograms to draw bar graphs of how our data process. These 2 diagrams show the number of data points that traverse the pipeline, and then the side on with the green bars show when data points have failed to traverse through the pipeline. There are many reasons why data points fail to make it through a pipeline. It could be that they failed the validation step because they had invalid schemas. It could be that the data itself was malformed. Or it could be that there was a system-wide outage at that time for our API when we were trying to load the data. But it's important for us to at least have visibility into when data points fail to make it through the data pipeline. I want to leave you with this. The goal of interpretability and observability is to arm you with knowledge that you might not have. There's no good way to solve problems that you are not aware of within your pipeline, and there's no good ways to, you can't improve on what you don't measure on. And that includes your models, your pipelines, but it also includes your alerts. So it's important to understand what threshold and tolerance you're willing to work with in terms of monitoring and alerting, and be able to set that baseline and evaluate as you go. Maybe you have a ton of metrics in your monitoring system that you honestly don't need anymore, and it totally makes sense to remove those metrics and put them into a separate spot so that you can have access to them. It's more important to be able to debug and understand a system than it is to try to solve for every possible problem that might come up. And that is it. Thank you so much. I'm happy to take questions outside, as I know another talk is coming in. And as always, Button is hiring, so please feel free to come talk to me about that as well.